Alright. Oof. Okie dokie. Let's get this adjusted here. A little bit wider.
Banks and banks of humming machinery. I've never seen so many knobs. Here, try that button over there. No. Check that button over there.
Okay. So here we have an Onkyo receiver that my cousin's. He gave it to me because it does not turn on. So I did plug it in, checked it out, and it goes into standby. Standby light comes on, but it doesn't do anything. So let's explore. Well, that's dusty. No, we're going to go for all the obvious things. The fuse is the first one of them. This obviously is not plugged in. Oh, that's kind of cool. I can get the power cord out of the way. Sweet. It's in there pretty good and tight. Neat and tight. Visual inspection looks fine, but let's just check this with the multimeter. Yep. Okay, so it's not the fuse. Test one down, and then kind of look. Wow, this is really dusty. Kind of look through and see if there's anything obvious that's wrong with this. I'm not seeing anything sticking out as very obvious. Okay, or maybe even the switch. Must come through this wire. Nope, that's infrared. Nope, there's this. Well, the signal is actually coming from this board. I'd like to find out where the voltmeter is on that. Just to make sure it's not a dirty switch, considering how dirty the inside of this is. I'm gonna guess in this location, it's gonna be one of these pins. I should get a schematic at this point. So if we know it's not the switch, and we know it's not the fuse, then let's get ourselves a schematic and trace that line and find out where it's actually going.
Okay. What do we have? All the fun. Well, the standby is coming off the microprocessor. That's good. Power switch. No different resistance values. This may not be a very simple thing to fix. Let's see what we've got going. Where is this coming in? K0. Key operation connection pin. Wow. Power set source control output pin. circuit board parts. Schematic diagram. Don't think this is going to help us a whole lot because it's in the microprocessor. Huh. Let's see if there's anything that I can see that would make any difference whatsoever, or this is going to be a real short video. And the schematic right now. And it looks like right in here is where the signal should be coming in from the front panel to tell the relay to switch over. So I'm just trying to find a spot where I could actually run a test lead on it. Let's see if we get that power signal coming from the amplifier. So we want to be reading, get any sort of voltage or signal or anything. Set us for 12 volts and I'm going to plug this puppy in. Goes without saying, be careful in here. Messing with electronics. Alright, well, it has power. And we're getting nothing. Nothing. Power there, 14 volts. So that is PO2. So POW on the very end. Maybe. There's 13 volts there. There's nothing there. 13 volts there. And nothing there. Brief change. So that signal should be coming in. Let's see what we've got. PO2. And POW. And that's the one that we need to turn on. It should be sending a signal to the base. Does this mark which one's the base? No, of course not. But what power should be sending? It doesn't tell me anywhere the voltage that signal should send, because it should send it, and it probably, once it's on, it holds it and it keeps it on. Continuity checking. Checky. 2.59. I think that the diode is not working. It's not 4148. Alright, I have some of those. Got the box of diodes. 4148s. There's a 4148. Those I have kicking around. Turn on L soldering iron O. And let's see if we can make some damage.
Ooh. Uh-oh. That went flying. Flying into the amplifier. I don't see. Oh, there it is. Okay. Just to see how this behaves. Let's test it outside the circuit, as it could be just in the circuit. It was. It could be that it's fine. Alright. Well. Yep. And so it was just in circuit. It's doing just fine now. Alright. Not the problem. Still thinking the microprocessor is busted on this. But we will leave no stone unturned. Piece of solder. Sad outro. Putting all the screws back into it because there's no helping it. Well, I have some peanuts because really this is way modern for the sort of things that I work on. So not my normal wheelhouse sort of thing. Sad, I tried to make a fourth video and turns out not to be a very good one. Typically I work on like late 60s, early 70s sort of stuff, or at least stuff that's more or less computer controlled, less chips. But I suppose I should learn how to deal with testing computer chips and whatnot. But I mean, this is a specialized chip in there. If it's dead, there's no fixing it. It's done. That microprocessor is, you're not going to find a replacement. So